Yeah.
Without like completely wanting to just kill themselves.
Yeah, it's a different thing.
It's not about having the knowledge.
Uh-huh.
It's about having
the want to and to see the details. Yeah.
Anybody can read it. Want to read it.
Yeah, I got that. Not at all. I understand what you're saying. Well, let me go ahead and get us started here. I think we got one. We'll have some people join us, and chapter 16, which deals with cross joins, self joins, and cross tab queries. Probably we'll skip the cross tab queries for the very simple reason I just think, well, we'll look at it and see what it looks like in Access, and you can judge for yourselves. So what we're going to do here is grab I'm down on my desktop, the SQL fun file, and I'm just going to take it and one of them. It's basically my warehouse and paste in, and then I'll do chapter. I'm going to rename this chapter 16. So as you're uploading these, you should have them now. I don't like the cross-tab function in Excel, and when we go there, I think you'll start to understand. I frankly believe that the author just does it because they're covering, show you cross-tabs. I think you're going to be a lot better off. You probably will at work be doing much of that using a product. You might be using Microsoft Pivot Table. You might be using SAS, SAP, SPSS, Oracle. I doubt that you'll be using the cross tabs function in Access, although in theory or in principle, for you what you've got there. So I'm going to go ahead and open this up, SQL Fun, and then we'll need to go get the files, the text files for chapter 16, and we'll work through these. The whole idea here, as we've talked about before, is moving us on into that area where we're really starting to utilize the idea of the analytic cube, and we start to utilize the power of large numbers by tying tables together, etc. So we're going to kind of continue that along that realm. However, we're going to be some more creative uses of this, and you'll see what we're talking about. Now, over on page, the text, chapter 16, starts over page 599, and they give us the definition of a cross join, which is basically a Cartesian product. And remember now that when we work with a database, unless it's a non-SQL if it's a non-SQL database or a non-traditional database, you're going to be working with records. You're going to be working with columns. So when we talk about the Cartesian product, the authors give it to us there. The column in the cross join is the sum of the number of columns in the beginning table. And then the rows in the cross join are the product of the rows in the beginning table. So that's, and the authors immediately start talking about this idea of the Cartesian product, simply because we're moving to that point where we try to leverage out tables and tying them together. Now, at the very bottom of page 599, we start with 16.1, and let's take a stab at that, and we'll talk about what we're looking at. Today, in the business problem analysis course, we went through pivot table, using the pivot table, and it just never ceases to amaze me how good the pivot table, what a very, very useful tool that it is. It's just incredible. And the nice thing is it's exceptionally intuitive, and but it's the progenitor of a lot of those types of products out there. Now, we're going to run this query, all right? And if you go over on page 692, this is going to make some sense. We've got two beginning tables. We've got F column underscore one. Pardon me, this first table is 1601 columns 1 to 2. And then the second table is 1601 columns 3 to 5. So you say, are we working with the same table? Yes, we are, okay? But what we've done, by using the table aliases, okay, we're able to tie them together and get more data than we would have otherwise. And if you'll notice there over on page parts, it's 599 is the bottom, is where it has the code. And at the bottom of page 600, you're going to notice there are 5 columns, okay, and there are 20 rows. And you've got and that falls. So from those two tables together that have 1, 2, 3, 4, 5, 6, 7, 8, 9 records, we generate a result table with 20 records. And if you look at them fairly carefully, what you're going to see is that there are 5 groups of 4 that get you the 20 records. So we leveraged that. Now, we didn't split the table here. I'm sorry. We used 2 tables that we tied together using a table alias. So I apologize about that. There are 2 distinct tables that we pulled into one. Okay. Now, one of the things we didn't spend a lot of time on, and I don't think it's useful for us to do this, is to talk about what we call normalization of a database. And COD's 5 forms of normalization. The very first one is, does every table have a primary key? And I think of it like this. A table ought to be like a paragraph. It ought to be about one thing. And for example, if I have, let's say I have a table of employees that has their years of service, okay? I would have their last name, their first name, when they started, are they still with us or not? I might have some other data about what departments they've served in. Are they in management or not? But it's really about those employees, the time they've been with us. And so if I start mixing in all other stuff like their address, their phone number, their email, all this, I've wasted a lot of time. The classic normed table is one that has a serial or an auto number, has a last name and a first name, and then an address. That would be, because that's a contact. That might be an employee table. That might be a contacts table of your customers, and you might want to include a company. So if we do tables right, if we design them correctly, we can really start to leverage the information that's in them. And if you look at those 2 beginning tables up there, you'll see that's on the top of page 600. You've got that columns 1 to 2 table, and then you've got the columns 3 to 5 table. Okay, and under this Cartesian join or this Cartesian product, we get the sum of the columns. We end up with 5 columns, and then we get the number of columns, and then we get the rows, which is going to be 4 in each of them, and away we go. So it takes and it will work with equal number rows. Okay. Now, you'll notice also if you take a look back on page 590, well, let me show you up here. I might put it through there when I could do this. And I'll just take her back to the SQL view and I'll show you. Notice what we did here, okay? We selected everything out of table A. We selected everything out of table B. That's the B dot asterisk. And then we got it from, and then we named each table A and B. Okay. Notice there's no where clause. There's nothing in terms of joining them. All right. There just simply isn't. We just ran the two of them and related them and got the cross join. Because if you look down there, you're going to see table A, table B, and then you don't see any other language like where, etc. Okay, and you ask yourself, well, you know, okay, what did we do there? Well, we just joined them together, but we didn't join. We just forced them together. We didn't use a relational. We didn't use a relational term like a where clause or anything like that, where, you know, table A equals something in table B. And again, this is, pop over for a minute and then give you some more context on it. And take a look at page 613 if you've got your book. Now follow along with me. I'm going to go left to right. This is the middle of 613. I've got a beginning table, 1. I've got beginning table number 2. Okay? And then I avoid a large cross join by running 2 different queries. I do a cross tab, okay? A cross join, and then that second step, and then the third step, I generate a query and get the result table. This is just a more efficient way to do it, and it allows us to not have to rely upon a whole lot of detailed conditions to get the 2 things pulled together. And again, all we're doing is just simple select statements. That's all we did. We selected, and then we identified what table A and table B. Now, if I look there at the page 600 and I see that table, here's the point where I'm going to try to extract some data, or I might run this result table, name it something, and then do another join and just replicate the process, or take the approach that the authors also show us there on page 613. Now, if you take a look over on page 602, and this is 16.3, okay, and we're going to run this. So let's go back to the text files, and I'll show you what we're talking about. So I'm going to go over here where it says 16.3 is a selection from Dual. So we're working with code that works for both Oracle and Access, SQL. Got that. And I'm going to click Create. And I need to save there. So this query one I've got, I'm going to say, we're save it, guys, is 16-1. Okay. All right, and now I'm ready to go. I don't want the query wizard. I want the sign. Here we go. Now, this time we've put in a conditional statement. At the end of this, we've said where A.F underscore number equals B dot C underscore number. So we're assuming that there's going to be some matches on the basis of records. So I'm going to run this. And here we have the fruits and the fruit number, the color number, and the color. Now, This I know is a really small scale kind of example, but think about what you would do if you were building and running these queries on table after table that starts to build a profile of a person. This is what happens to us all the time when we shop. They just simply keep building that, and they get a new result set till we do something different. And that's why if you go shop for shoes, or you go shop for anything, you buy something online, you're going to start to see banner ads. You're tired of, you'll see the stuff, sometimes you'll see the stuff you bought just live and think, why are they wasting time and money? Well, obviously they're thinking maybe we can cross-sell you or get you to buy something else extra. Let's look at page 602, and you'll see we've got this first step where we've run these two together, okay? And we've got the fruits table and the colors table, and the authors are walking us through what's going on with the machine because of the conditional statement, and we end up with the results set at the bottom of 603. And basically, when we run this, we're doing a cross join of these tables, and we're joining them on that fruit number and on the color number. Okay? And that's, again, taking those two bits of data. We generate all of those, that first table, which is it's generated or view, but you and I never see it. And then it evaluates the join conditions. So it runs through all of those, and then it ends up with that result set. And that's why I talked some with you about indexing, because you'll notice, look at all of the rows or records that the machine's going to cull through. So that's why you want to index if you're going to use large numbers. But this whole thing is about leveraging large numbers and looking for data patterns in them. Then the last step, you get the inner join, and away you do, and away you go. A lot of this is going to be strategy. Okay. Now let's talk about that for a minute and take a look over on page 607. Okay. And this is going to be 16.5, and we'll pull the code up and talk about it for just a minute. You say, what do you mean by strategy? Well, let's look at it. Okay, I've got two tables. I know that because I have them identified, lunch items, and then the lunch items, and then the foods, table A and table B, I've got them identified. Okay, and I'm strategizing because I use a where statement right here, okay, and right here, and then I use an and, so it's got to meet both conditions. It can't be either or. I'm using an intersection when I use an and. So I'm strategized by winnowing down to an exact set of data that I want to get. And the authors give us some pretty good verbiage prior to that, but if they show it, they show us there at the bottom the correct table, and they show you an incorrect result table above. But look at the correct result table there at the top of 608. Now we'll run this, and we'll extract the data out. But this is just strategic, and it becomes a question. This could be, we're dealing with these lunch and the food. This could be an item that somebody bought, the size of the item, shipping preference, currency. I mean, you could just keep adding in as much as you want and call the results set and just keep winnowing the thing down, okay? Because you'll know there's going to be some definable patterns. So we'll click C, we'll copy that, and then we're going to put it into it. We're going to create a query with it. And most of this really is just about once you've thought through the dimensions. In other words, you've built the tables, and just like when we looked at the data warehouses, and we went to Northwinds, and we saw the fact tables, and we saw those dimension tables, and we've had the same things in here like tables of constants. Once you've worked all that through, you're really behind the eight ball for a very simple reason. You can really just keep throwing conditions in to winnow it down to a particular result you want. And I think that was 16.3. So I get to talking. I forget to go ahead and just label that. But this is the part where we're not just chunking numbers, but we're doing some thought. And I'm going to say this would be 16.5. You say, well, okay, where do you keep adding all these conditions? Well, it's pretty simple. I keep adding them at the and I'll go down to the SQL view and show you. Where and I could add another and to pull and cull even more out of those two tables. Now they're related, they're linked on the basis of the supplier ID. Okay. You say, well, could I add an additional where statement? Yeah. As we get near the end of the book, the author's going to show us some of that. And where we're really culling down from a set of numbers, and we end up with the correct results set over there on page 608, and we end up with 1, 2, 3, 4. We end up with 4 records there, and the records are the lunch ID, and you'll see those 4 there. You say, well, why are you so focused on the records? The records, okay, are where I can look for patterns. Now, this is a simple example, this 16.5, but again, think, what if I was talking about 2 tables that between them had 500,000 records? Now I'm talking some data. And if I pull 2 tables that have 500,000 records, and I'm looking for a pattern based on those where statements and the and, so I'm really honing that down, and I get 50 records, I've just hit go because I've found records that will indicate persistent or important patterns in the data. And let me explain what I'm talking about when I say that. Let's look up here for a moment, okay? Now, we know if you keep looking at that, you're going to see we've got fresh salad, soup of the day, sandwich, broccoli, french fries, soda, coffee, dessert. A persistent pattern in this case is, of course, because we're working with the food. But notice the prices and notice the quantities. There's a pretty set range in terms of the price and the quantity that are listed there. And that's the kind of thing that we start to look at. Now, it's not as evident with the small, but once you scale this all up and you start to see the same kind of band in terms of pricing and the same kind of band in the terms of the quantity, if this becomes a recurring thing, say, for example, something you could filter, then you've got some results you can work with. And the end of all of this should be that I can take large sets of data, I can extract from them, and I can look for what we call persistent patterns. And that could be a single fact, like they were all phone calls to 405 area code, or it could be within a range of facts, like as we see here with the price and the quantity. Now I've got a hold of something, and something that I can work with. And the authors do a fairly decent job of explaining that, but that not too bad. Now, page 609, and again, he starts talking about over on page 608, the bottom of 608 to 609, he talks about using cross joins to list all possible combinations, okay? Now, let's say that you let's say that you make clothing of some type. You're going to want to know, well, what would be all the possible combinations I could get? Short sleeve, long, the sleeve length, the material, any markings like piping, anything like that, long or short sleeve. And you start to look through that, and then you've got to look through the range of sizes, and then maybe styles for females versus males, or women versus men's. You want to look for those combinations. Once you do, you know what you'll need, what you want to make, and then as you start to see a persistent pattern emerge, and that is, I don't sell many red polo shirts, but I sell a bunch of blue ones, and I sell a bunch of black ones. Well, that's going to have some implications for me in terms of the inventory control that I have and in terms of my selling. So if I'm selling a bunch of black and blue ones, that's where I'm going to go until the market starts to tell me something different, or the orders start to tell me different. But if I want to have all that displayed in my e-commerce store, I've got to work my way through all of that. This can also apply to things that can go wrong. Airline pilots memorize this stuff all the time. Of all the stuff that can go wrong, here's what you're to do. And the thing with the 737s is it appears that there was a fix where they shut off a function on the software, and that was all they had to do. What they kept doing was trying to use an autocorrect, and they were making their situation worse. Now, the same plane that went down the day before, there was a guy riding deadhead, a gentleman who was a pilot, and he'd been through the training, and he had been forced to memorize every single thing that might go wrong with this new system they had, the anti-stall system, and he said, shut it off. Now, it's easy for us to sit here and Monday morning quarterback, because the 737, if you've got 3 people in the cockpit, you might as well have 1,000, because you got all those sensors and all that data and information. And pilots, one of the great fears they have is they overload on the information, and the system just gives them, they have all these alarms and things that go off, and one thing sets it off, and then everything else starts to work around it in these fly-by-wire arrangements that they've got. So you might be wanting to try to find out, hey, what are all the possible things that can go wrong here? Then maybe work for remedy. Well, they give us a little more mundane type of example here, where they talk about car types, okay, or I guess you wouldn't call it a model, I guess car types, and then the colors. And notice we worked this into a 2-dimensional grid, okay? If you're lucky, which you probably will be, you'll go to work for somebody who's got all this stuff down, and when they feed you your data for your dashboard, you'll already have data that you need and the stuff that's most important, the KPIs. And that's like when we looked at Northwind Traders, you had things like, okay, what orders do we have any overdue orders? How much have we got in stock? That kind of thing. Well, up here, we're looking at the options as a 2-dimensional grid, and they literally sit down, the authors show us this, right? I mentioned this today with students in the business problem analysis class. I do quite a bit of work with churches on their databases and some other types of studies like growth studies and that type of thing. Don't get paid for doing it. It's a goodwill thing to do, etc. But one of the great problems I have with them is when they get a system and there's a system out there that almost everybody buys, it's called ACS, which it's a fantastic database and analytic tool for a church. It all revolves around a church as an enterprise. Now, the problem is getting people to impose query discipline. And you say, what do you mean by that? What do I mean by this? And I'm at the 2.5 to 3 year juncture with one place I've had to walk them through the process of here's why you want to schedule these reports for Monday, these reports for Tuesday, these reports for Wednesday, these reports for Thursday. And then if someone comes in and says, can you tell us how many people with red hair came to church this morning? You've got Friday to run that through. Why? Because the query discipline focuses you on the reports that you need for your operating condition and reports, some places do, but not many, in terms of the environment in which you're operating. Churches tend to be more very inner-oriented. The idea that local conditions might affect them seems often to go right past them. But if your neighborhood or the demographics changing, you will change, or you'll shut the doors and go somewhere else. But imposing that kind of query discipline. So this process here where he's worked us through forward, white, red, and green is a discipline that I impose in saying, what do I need to know on Monday? Well, there's some things that are intuitively obvious. I want to know what? How many people were in Sunday school or life groups, whatever you want to call that? How many people attended service? I need that data. If I have 3 life group services times, you want that. You want the attendance at each of the 3 services. You want how much they gave. You want to break that out into contributions. If somebody gave it, for the building fund, put in an envelope marked Lottie Moon, any of that stuff. Tuesday, you have another set of reports. Maybe Tuesday would be all the reports of everybody that's in the hospital. And trying to work folks through that, to impose that kind of discipline, is very difficult. And so I'm off on this spiel with all of you so that you understand. You'll know pretty quickly if you're working for a place that really understands what they're doing with this or what it can do. If you have a pretty strict discipline, or say a calendar of reports, if you don't, hold on to your hat, because you're going to be running all kinds of queries all day long, doing all kinds of work like that. Often it's going to be someone pops in their head in the door, and your boss usually goes, hey, could you get me some data that tells me about blah, 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 blah. And then you have a thought problem on top of all of it. Well, if you look across, they walk you through that whole process there in 609, okay? And they walk you through the cross join, and they're on those car types. And let's go over on page 610, and we'll see 16.6. So this course is more about you understanding how to manage this. That's why it's called data administration, because if you're working for somebody, okay, and you have a boss that just wants you running queries, that's a point where you maybe, after you've had the time to settle in, to sit down and go, what is it that I really need to provide you with? Because if your boss can't tell you that, it's pretty simple, obvious that the people above them may not know what they want. And so if you're asked to run just a whole bunch of reports, it's not a bad idea to say, okay, help me, especially if you're new, say, can you help me understand, what am I doing here? Okay, because I want to understand how the company operates, etc. You may or may not get a good answer. And so as we move into this and you see this idea of a Cartesian product, you got to be thinking about, what am I after? What do I want? Okay. I walked the students in 1123 today through a pivot table where we had 7 columns. We had 5 dimensions, so we had 5 columns, and then 2 fact columns, units, and then dollars. And we had 900 records. So we had 6,300 records. How much information is contained in that? Well, people who are experts in information resources will tell you that you should get about 5 bits of information or insight out of every 1,000 rows or records that you have. So there's about 30 insights in there, or bits of information, that is data that can help you make a decision out of all of those 6,000. Well, let's run this, and we'll copy it. And so we'll click create, and we'll do the query design. We'll close this jewel off. Okay. And here we go. And here we have the car type and the color. Now notice I've got multiple cars, multiple colors. I also have multiple colors, multiple cars. Follow? If I start to talk about products, you know, how many sizes of green beans do I have? I'll bet you if I went to Bentonville, if we all went over to Bentonville, Arkansas tonight and walked in and said, in a typical Walmart store, about how many types of deodorant do you sell? I bet you they'd probably come back with a figure within about 15 or 20 seconds, and then they'd say, are you talking about men's? Are you talking about ladies? Are you talking about, because they'll start to go through they'll start to go through those classifications, categories of those. They have to know that so they understand sales patterns. So here we've got the colors table, the types table, and we've melded them together. So all of these different possibilities per car type and per color. That makes sense? Yeah, anybody not understand what we're doing here? Okay, yeah, I mean, you know, it's that simple. And you know, like I told you, I had worked with some folks 2.5 years to get them to tell me what is it you need to know on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Or what do you need to know Monday through Friday? And it was a very frustrating process for both of us because they kept changing their story. I kept telling them, you keep changing your story. The first struggle with them was to get them to give me complete records. And we've talked about null data before, and getting a report where you go, is it null? Is it a zero? And we've gone through some exercises where we had those kinds of problems that we had to address. These technologies are, most firms use only about 20% of the capability of the technology they buy. So if they spend $50 million, they'll probably only get $10 million worth of it. Yet people see going, why can't we get more productivity? And typically the reason is not this technology itself, it's the people who use it and who often misunderstand it or don't use it well. Well, that's 16.6, and so we'll save it as such. Then they give us two-dimensional table layouts. And this is over on page 611. Other layouts when they're more than one dimension. And then again, over in 613, they walk you through that process of the beginning tables. Second step, we create a cross join, and a third step where we extract data. And so there's a very continued process, but because we're walking through that, all right, we want to make sure exactly what we're after. And it never ceases to amaze me that seems to be such a difficult process to grasp. But the truth is, when people get a toy, even if it's a database, they want to just play with it. And I give you, for example, a good example. I couldn't wait till I'd be 16 so I could get my driver's license and drive. I remember my dad laughed and he looked at me because I wanted to drive everywhere, and he said, when you start paying for gas and tires and maintenance, cars don't seem like such a fabulous thing. And he said, when you go buy a really nice expensive one that's a really top line, you'll spend even more money. And they can be a money pit. So think about that. And the first time I bought a really, really nice bass boat, my dad laughed and said, you know, the happiest days of a boat owner's life, he said, the day they buy it, the day they sell it. And he was right. I had a money pit. And same story. I bet all of us, any of us who are males in here, you couldn't wait to shave. I remember I could never wait to shave. I was saying, when do I get to shave? Now I go, oh, I have to shave. After 20,000 times, I'm going, the repetition of it's a little bit much. Well, let's take a gander over at page 16.9, and pardon me, 614, and we're going to do 16.9. Okay, and we got a pretty typical query. We've got an A and a B. Okay, and we give them a column, and we give those tables an alias, and then we identify them. Now we're going to form the cross joint of a table with itself, and let's talk about this for a minute. I've got A column 1, A column 1, B column 1 as column 3. I use a column alias. I trick the machine into thinking there's a third column. B column 2 as column 4 from section 1609A, section 1609B. Information resources are inherently reproducible. They can be reproduced to the extent you have the technology to reproduce them. And today's news becomes history, okay? And so people will archive it and all of that. Same thing with movies, same thing with music, any type of intellectual property. They will often gain value with age. But we've got this, and we've done basically, we've joined this table. We have the beginning table, which is the 1609 table, and we use the column alias and the table alias to duplicate this one table. Okay? And we'll do it, and then we'll run this and take a look at the results set. And again, we're trying to leverage this data. And so here we go. There's columns 1, column 2, column 3, column 4. Now, I'm going to run a query like this. I'm going to do a join of a table with itself to look for any kind of pattern that might exist there that I would miss not looking at the two tables. This is a synergy that we try to obtain from tables if we possibly can. Now, so what kinds of tables do you typically do a join on? And they're typically going to be fact tables. And we'll try to do a cross join of a fact table to see if we can find a pattern. We're always looking for patterns of data. Now, the authors give you just a little hint at this over on page 615, where they talk about the two lines include G and H, and how we've used that cross join the beginning table to generate this even larger table. Okay? Now, page 616 in the textbook, this is 1610, they give an example of a self join, and they do that using the tables here, the employee information, the manager information, we tie it together, and then they show us the information table for the employees, one for the boss, okay? And then the join condition, as I mentioned there, is the employee manager ID equals the boss employee ID. And that's that 1610 where they walk you through that. Notice what they're doing here, and I'll go ahead and let's pull that up so we can see it a little clearer and think about it for just a moment. Okay. I've got an employee's table, ID, last name, phone number. Then I have a boss's table, last name, but I convert it to manager name. I give it a column alias. I do the same thing with the boss phone number. So far, so good. And I pull that from the employee's table, and then I do a left outer join. Now remember, a left outer join is where I get everything out of the parent table, the table on the left, and then I also get anywhere where the table on the left, the parent table, matches up with the right parent, the right table. So a left join, if you think of a Venn diagram, the left side of it's colored in, the middle's colored in, and on the right side it's left empty. If it was a right outer join, it'd be just the opposite. And we use that to leverage this. We'll pop this in here. create the query and go from there. Now, they give us the output over there on page 618 and the result table, okay? And again, we've got a couple of null values there, and we would have to ferret through those. But we've done our cross join, okay? And so we've taken those two tables, bumped them up, but we use that join there on the manager ID and the boss employee ID, and you can see that there as you walk through the result table. So it's really just about leveraging that information, how I've got it. Now, the authors take a little bit of a different tack with us here in 1611. I want you to take a look at it for just a second. And all right. I'm going to run this 1611, but I have to do a little bit of work with it. And so we're going to come over here and we'll delete this. And a time done. And then I want to get rid of the parenthesis right here. We're adapting it over from Oracle to Access, and that's a start time. And then I'll repeat that process because it's got some Oracle language in here. And I'm going to get rid of the parenthesis, B time, and I don't need the parenthesis because I'm not using that to character. If you look at the text at the bottom of page 619, okay, the Oracle SQL uses to character, and what that means is turn those into character type data. And then we've got the time done, and here the parentheses inside the time, and I'm going to use the round function out of Access has been selected. Let's see what happens. Maybe I did a little bit of cut and paste with this jewel and cobbled together something we can look at. We'll see. I just did some tweaks. May or may not be successful. We'll find out. Let's see. How about that? Okay. By joining these, we're able to show sequences of events. Okay. And if you look at 619, let's see what they're talking about. First of all, I want to pop this up here for you. Notice if you have the book too, you're going to see that I took out the toCharacter function, which is an Oracle function. It says turn the data to a character, and a character can be. Access uses a variable character, which means it can be anything. It can even be a blank. It can be special characters, whatever. The toCharacter in Oracle is Oracle's underpinning software sniffs out a little better in terms of what do you mean by toCharacter. Okay. Access says, here's how we're going to handle it. We just won't write the kind of code they do. We'll just make it easier on ourselves, but we'll just have a variable character, which means anything goes. Okay. And then and this is that line. And then I got rid of the parenthesis. I didn't need it because I wasn't working with the function. Same story on this second line of code. I mean, the third line after the second after the select statement. And then I use the round function. Okay, and in the textbook, notice that they don't use that. Oracle doesn't use it. So I go ahead and put in round. I use the round function, and that's a numeric function. You can go over back in the chapter that covers that and see what it gives you or is supposed to give you. And we're getting the time done less the time in table B, the time done, minus the time done in table A, times 60 times 24. And that'll give us the minutes elapsed. Okay? And we're taking those times and we're treating them like a number. Okay? And then I've got the from events A, events B, and then I use a where statement where the sequence plus 1 equals the sequence B number. So I'm advancing them. I've got a literal in there, that plus 1, and I'm just advancing at each one. It's called a counter. And then I order it by the sequence number. So I did a little bit of work with it there, tweaked it a bit, and now I have the sequence of events and the minutes elapsed. So the time I started, the time it was done. I could just as well work with I could just as well work with, say, with money. It would just be up to me. Say a bank, say maybe an inventory. An inventory, I could, anything that's going to be serial in fashion where I'm adding, where I'm subtracting from a bank account or inventory. Now, adding the stuff back in, that makes it a little bit more complicated, but this gives you an idea of what we can do with this type of query. And they show you that over in 620. They show you the beginning events table and then the result table. Now, if I have 5,000 of these records, this is the time I dump it back into Access, or if I'm lucky enough, my employer has something like SAS Visual Analytics or SAP or Oracle. I'm gold because I can do some charting if I care to. I can take these elapsed times, put them into a chart. I could compute some summary data and statistics, so I wouldn't have to just give you one picture at a time. I might even illustrate. I'm looking at what I'm looking at here are nodes in a transportation network, a segment of a transportation network. I delivered the package. I picked up the package. Okay. I started a lunch break. I ended the lunch break. I delivered a package. Picked up a package. I picked up another package. I delivered a package. I delivered a package. Okay. Now, with this, I would probably have my starting and my ending GPS. And because I'm a driver, I'm delivering this stuff, the company would have the starting and the ending GPS. Ask themselves, did it really take 12 minutes to get over there, 8 minutes to get over there, to get over there? And if you've got stuff and you notice, UPS, FedEx, any of those people, but especially UPS, when they deliver something, I've learned to go right out if I can be there and meet them. I always ask for stuff into the evening, and if I can be there, I can go to. Otherwise, they're going to take that package, they're going to run to my door, they're going to throw it down, knock on the door, and run back because they're under time constraint. But you can see I can work this schedule through as much as I would want to. If any of you have a Google phone, all right, let me show you something quite interesting. If you've got an Android phone, you may. If you don't, maybe not. Okay? And I'm going to go over, I'm in my account. I'm going to show you something quite interesting. And this be me. Okay? And I'll show you an example of this, but using what they call GIS, Geographic Information System data fed in. And if you've ever seen, probably maybe you've seen this, but you can click on your timeline, okay? And Google, through my phone, will locate everywhere I've been. Now today, I've been a good boy. I went from work, I left at work, I left home and I went to work. I didn't stop at the gentleman's club and have a beer like I usually do on Thursdays because I got to work late. I didn't go shoot pool. I came right here. Now let me show you one other thing. I'm going to click right here and you could show raw data. This will show me the exact time. So I can see the elapsed amount of time and if I'm moving or not or anything like this. The data here, they say export this data to KML. KML will let you take every single piece of that route, that blue route, that's me from home to work, and it will break it down using the GPS point by point by point by point so I can see in great detail where I went to. And you can see here, my wife at home, who probably is watching me, I wouldn't doubt it, is, okay, where was he today? Oh, okay. Okay, so he didn't stop over and have any wine with Dr. Flint or anything like that. All right, okay, he's been a good boy. He's been there. And I can even show her, I've been here at Bailey Business Center all day long. Look at that. See? Isn't that fascinating stuff? Now, if you really want to have fun with this, okay, and this one's pretty crude, but see, I've been here. I had to go over there today. Go and complain about some stuff I was having problems with. This is exceptionally accurate. And watch how I put it on satellite. Look at that. Now, they're not sure how I got over here. And what I did was, of course, I stopped in here and went and complained to the IT people about some trouble I'm having. And then I hightailed it back down University and whooped around and came back over here to the parking lot. Now, I was here, so I can say, yeah, honey, I was there. And here I am right now. So, interesting. So if you have an Android phone, kind of interesting thing you can play around with. But what we were working with there, same sequence. And we're just really now starting to see what people can do with GPS. Let me pop this back in here because I knocked this off the line, but that's okay. As long as I'm still recording, we're good. So, and I'll log in here. And I'll log in and away we go. Now, if I could track, for example, a sequence of events, I can also track, I'll take us down over here to, here you are. I can also track sequences of purchase or purchases. Anything that's sequential, I can do that. Look, like 622, the bottom of the page there, generating numbers from 0 to 999. That's not a thrill for me, and I doubt it would be for you. So we'll pass the buck on that one. Now here they walk you through the crosstabs query. Okay, I don't like the crosstabs in this. I don't like the crosstabs query for a very simple reason. I just think it's very cumbersome to use. And the text does a pretty good job of walking you through it. Frankly, you will be smarter to go and use an Excel pivot table, okay? Because it's going to do a lot better job for you. They show you some cross-tab queries with dimensions. Let's see what we've got going on here. And you have to run all kinds of steps to get the result tables. And I don't know if it's really worth it to go through all that. They also walk you through the using the crosstab function in Oracle. And if I thought it was worth your time or energy, I'd have you do it. Now, so we've got this, and I'm going to call these 16. You could call whatever you want. I'm going to call this 16. I think this is 16. 7. And I'll call this 16.8. And we're going to do a little bit of work in chapter 17. At least get a bit of a start. And this will be 16. I'm going to call it 16.10. For purposes. All right, now. Over in 16.10, they start talking about combining 3 or more tables in a production database, okay? And we talked about this at the very start of the course about what a production database is, and like Northwind Traders, that Excel file that we worked with, it's a production database for a very simple reason. It's intended to produce reports for us that we can use in running the business or understand in what's in operationally, or even, most production tables are really more about transactions, internal and external transactions. So they talk about how to use those. And over on page 656, now they start out with, and I'll walk you through this, they have 1, 2, 3 views. And if you look at the bottom page 656, you're going to see create or replace view, 1701A, then create or replace 1701B, and they tell you what to replace it with, and then 1701C, that view. Now, in each case, whether it's A, B, or C, they identify the tables, and the tables are employees and lunches tables. And again, the lunch, and then again, you see they've identified those 2 tables, and then they walk down in that part B, okay, and they walk you through the tables, and that's view is A, and that lunch items is B, and then you get the result table over on page 657. And they give you some information about using this with an Access SQL and a little bit more problematic. 658, they walk you through joining several tables using the where clause. And that's, pretty good to see. And I think probably what I'm going to do is, we did start a little bit early. And I think what I'm going to do is probably leave chapter 17 to do part 2, because there's some cut and paste in it and some fairly complicated stuff that I want to feel free to cover it and for you to be able to chunk through it. To get through 17 will probably be an hour and a half or so. So I don't want to do that. And I don't want to get through part of it. So I think I'm going to call this a day right here. I appreciate you folks who are out, you two who came, and the rest of you who are out there in TV land. And I'll do a part 2, which will be chapter 17. And we'll start talking about doing 3 tables at a time and on and on. Okay? Thank you much, folks. Appreciate it. Have a good one now. Oh, before I stop, anybody have a question? Okay, we're done. Thank you.